Okay, so in this unit so far we've looked at solving triangles, solving missing values of triangles using the sine law or the cosine law, whether that's missing sides or missing angles. And I pointed out that in all cases, the type of information you're starting with is different. And that's how you determine whether to use sine law or cosine law. We're going to look at a couple of examples where you have to be able to determine, based on the information you're given, which would be the better way to go. So when solving trigonometric problems, we're going to decide whether to use sine law or cosine law. And we're going to solve the problem using cosine law or sine law. The outcomes we're going to cover are: solve a problem using the sine law or cosine law when a diagram is given, and describe the use of the sine law and cosine law in construction, industrial, commercial, and artistic applications. Okay, so given a triangle such as this one, triangle ABC, how can you find any unknown angles or sides in this triangle? Let's try the sine law first. Let's see if we can get something out of the sine law. Remember, the sine law is A over sine A equals B over sine B equals C over sine C. Or it could be written with all of our ratios flipped from that, reciprocals. Let's fill in what information we have, though, from our diagram. I have side A is equal to 11, side B is equal to 5, and angle C is equal to 25. So using sine law, in no cases here do I have a completed ratio. In all three ratios, I'm missing a part. In a situation like this, it's impossible to use the sine law because we just don't have enough information. So we can't identify enough to use any of the three ratios. We need two angles and a side, an AAS or an ASA triangle, or two sides and the opposite or the uncontained angle to use the sine law. If we were to look at this triangle here, what we have is a side here, then I have the angle right next to it, and lastly, I've got a side again. So this would be an example of a side angle side triangle. For sine law, we need angle, angle, side, or angle, side, angle, or side, side, angle. Okay, so we're going to try the cosine law now. If you recall, cosine law should work for side, angle, side triangles. Okay, we've got a bunch of different versions of the cosine law. We're going to try them all. We're just going to fill in the information we have. So we know that A is equal to 11, B is equal to 5, and C, angle C is equal to 25 degrees. So I fill in my known information once again. What you might notice is that in the first one, I have two missing pieces of information, C and angle A. In the second one, I have two pieces of information missing. In the bottom left version, C squared, all of it's available, or all of it's there. That's perfect. In the other versions, I'm missing C again. I'm missing C here. And I'm also missing C here. So this version's no good. This version's no good. This version's no good. This version's no good. And this version's no good. But what I do have is a working version of the cosine law right here. All the information that I need is provided. So the cosine law works to find side C. This triangle, like I mentioned already, is an SAS triangle. So I use that version of the cosine law. I'm going to plug this information into my calculator. I'm going to do it a bit at a time this time. So C squared is equal to 121. 11 squared is 121. Plus 5 squared, which is 25. Minus 2 times 11 times 5. I simplify that into 110 times cos 25. So I'm going to put this into my calculator, and I get 121 plus 25 minus 110 times cos 25 is equal to 46.3 with some other information there. So C squared is equal to 46.3. But once again, to find C when I know C squared, the next thing I'm going to need to do is to divide, not divide, get the square root of both sides of my equation. So C is equal to the square root of 46.3 and what extras. So C is equal to 6.8. So side C in this triangle has a value of 6.8 units. So we could see in that example a situation where sine law didn't work, so we had to go with cosine law. We're going to look at an example here to see which is the best way of solving this triangle, whether we should use cosine law or sine law. Jade works at a summer camp for children in Lake of the Woods, Manitoba. She takes small groups of children for canoe trips. The lake has a stretch of shoreline that is rocky, so she tries to avoid it. To do this, she takes an indirect route to get to the first campsite. Her route is shown on the map. By how much does she go out of her way by following this route to the nearest tenth of a kilometer? So we can see down here in the bottom right corner the route that she takes. All right. So the first thing I'm going to do is simplify my diagram again. Okay, so now I know that side C is equal to 4. This is a mistake in the diagram as it's written. Throughout you're going to see this is little c, but it should be little b. Side B is equal to 6 kilometers, so the direct route from where she started to where she ends is 6 kilometers long. She takes a little detour. She goes from A to B to C. We know that C is 4 kilometers. To find out how far out of our way she goes, we have to find side A. So we need to first find side A to determine her total distance traveled. In order to find side A, we need the measure of angle A. It doesn't matter whether sine law or cosine law, we need angle A if we want to solve for side A. So we're going to start with that. Angle A is the third angle in a triangle where we know the other two angles. And any triangle has a sum of 180 degrees of all their angles. So we take 180, subtract from it the other two known angles, 105 and 40, and that gives us a value of A is equal to 35 degrees. So we can put that into angle A. So now we know angle A is 35 degrees. Now look at the information we're given. We know all three angles, and we know two sides in this triangle. All we're missing is one single solitary piece of information, which is side A. So we have all but one side in this triangle. As a result of that, we can use either the sine law or the cosine law. If we have 5 pieces of information in a triangle, we can find the 6th piece by either the sine law or the cosine law. It's really your choice, your call on which you would prefer. And I'm going to demonstrate for you that that is in fact true, that we can use either version. So we're going to use sine law first. A over sine A is equal to C over sine C. I just chose side C and angle C to go along with A and side A and angle A. I could have very easily have chosen side B and angle B, but this was the way I went. You could have very easily gone with side B and angle B yourself. So I put in my known information. Angle A is 35 degrees, angle C is 40 degrees, and side C is 4. Now, the next step I'm going to do is, if you recall, I can cross multiply here, or I know that to get A by itself, right now I'm dividing by sine 35. So to get A by itself, I can do the opposite operation to divide, which is multiply. So multiply both sides by sine 35. Okay, and when I do that, I end up with A is equal to sine 35 times 4 over sine 40. Okay, so I put this into my calculator exactly as it's written, or in some cases you put in the angle first, then hit the sine button. Hopefully at this point you're comfortable with how your personal calculator works when you're doing a problem such as this. And we find that A is equal to 3.6, and that's in kilometers, of course. So A is equal to 3.6 kilometers. So her total trip now is from A to B to C. So she went 4 kilometers from A to B and 3.6 kilometers from B to C for a total of 7.6 kilometers when she took her detour. So how far did she go out of her way? She went 7.6 kilometers minus 6 kilometers, which is the direct route. So she ended up going an extra 1.6 kilometers on her journey. So like I said, this is using sine law. We found that A is equal to 3.6. She went 1.6 kilometers out of her way. But we can also find the exact same information using cosine. And I'll demonstrate that now. We know angle A already. We don't have to recalculate that. Angle A is still 35 degrees. To find A, the side, we're going to use this version of the cosine law. A squared is equal to B squared plus C squared minus 2BC cos angle A. That's 2 times B times C, of course, right? So we fill in our known information. A squared is equal to 6 squared plus 4 squared minus 2 times 6 times 4 times cos of 35 degrees. Oh, no need for that twice. So A squared is equal to 12.68 and other numbers. So A squared is about 12.68. So once again, remember that to find A, I've got to get the square root of A squared. So I've got to get the square root of 12.68. So A is the square root of 12.68. A works out to be 3.6. Once again, using the cosine law, I got the exact same value for A. So what this tells me is that it doesn't matter when I have enough information. If I can solve for sine law or cosine law, I'm going to get the same value. And I have to determine whether I'm going to use sine law or cosine law based on the given information that I'm provided in the problem. So once again, A is 3.6. So to summarize this section, when solving for missing values in triangles, it is possible you could use either the sine law or the cosine law. And determining which you use depends on the given information. You use sine law if you're given two angles and a side, either as in 2 angles and an uncontained side, or 2 angles and a contained side. So that's angle, angle, side, and angle, side, angle triangles. Also, if you're given 2 sides and the opposite angle to one of those sides, or in other words, an SSA triangle. You use the cosine law when you have an SAS triangle, which is a side, contained angle, and another side, or when you know all three sides in a triangle, which is an SSS triangle. The easiest way to evaluate whether to use sine law or cosine law is to identify the known parts and the unknown parts, the pieces you want in your triangle, and determine whether or not they're AAS, ASA, SSA, SAS, or SSS, and then from that, determine which law you're going to choose.